All right, we're doing section 5.2, which is integrating natural log functions. So yesterday we took the derivative of them. The derivative of natural log of x is 1 over x. So now we're going backwards. If we start with a 1 over x integral, the integral of that is natural log of absolute value of x plus c. We just have to make sure that we don't forget the absolute value. So if we're starting with this first one, 2 over x, that's the same thing as 2 times 1 over x dx, which is 2 times natural log absolute value of x plus c. Okay, so if it's not just x on the bottom, so like this one is 4x minus 1, then we have to do u substitution. So our u is 4x minus 1, du is 4 dx, and our du does not match what we have left, so we have to divide by 4. Now that it does match, we have 1/4 integral of 1 over u du, which is 1/4 natural log absolute value of u plus c, and then we put our u back in. Okay, find the area of the region bounded by the graph of x over x squared plus 1, the x-axis, and the line x equals 3. So it's the same thing as evaluating the integral from 0 to 3 of x over x squared plus 1. Our u is the bottom. du is 2x dx. And since there's no 2, we have to divide by 2. So we have 1/2 the integral of 0 to 3, 1 over u, but we need to change our two limits. So let's change those before we put this back in. 0 gets changed to 1, and 3 gets changed to 10 of 1 over u du. So this is 1/2 natural log absolute value of u evaluated from 1 to 10, which is 1/2 natural log of 10, or 1.151. Okay, here we have some examples. U on this one is x cubed plus x. Du is 3x squared plus 1, which is exactly the same as what we have. So sometimes we're going to be able to just recognize this right away and not worry about it, not have to rewrite all these steps. Second one, same thing. Let's recognize that right away. So if our u is the bottom, tangent x, the derivative of tangent is secant squared, and it matches perfectly. So I'm just going to skip right to the end of this. Natural log absolute value of tangent x plus c. If you don't see that, though, make sure that you go through and do all the steps like we did up above. Don't skip those. So this one is not a perfect match, so I am going to go through and do all the steps. So we have 2x plus 2, which means we would have to divide du by 2 to get our x plus 1 to match. One half natural log x squared plus 2x plus c. And the last one, our u is 3x plus 2. Du is 3 dx. We don't need the 3. So 1/3 natural log, absolute value, 3x plus 2 plus c. And notice how I just skip right to that point because I know that all we have left is the 1 over u, which turns into a natural log, so I don't feel the need to write all the steps over on these kind of questions. But you certainly can do that if you have any sort of doubts. Okay, this one, we actually have an equal power on top and bottom, so that means if we had our bottom being u, it would not turn out to be the same as the top. So we have to do long division before we can take the integral. Okay, so x squared goes into x squared one time. We multiply it back through. change the signs. So we get x remaining. So our rewritten problem is the integral of 1 plus x over x squared plus 1 dx. We can take the integral of these both separately. The first one is just x. The second one we're going to have to do u substitution. Divide by 2. Make it match. Let me get this out of here. Okay, so the integral of the first one is just x. The integral of the second one is 1/2 natural log x squared plus 1 plus c. Okay, this one. Our u is obviously the bottom, not the whole thing, just the inside. Du is 1. So there's going to be an extra x on the top. So what we're going to have to do is solve the u for x. We're going to plug that back in for the x. So when we plug this back in, that's 2 times u minus 1 all over u squared. 2u minus 2 over u squared equals 2 over u minus 2 over u squared du. We can take the integral of both those individually. The first one turns into 2 times the natural log of u, and the second one turns into 2 over u, which is 2 natural log absolute value of x plus 1 plus 2 over x plus 1 plus c. Okay, this one, solve the differential equation. That's just another way of saying we need to find the y. If we have dy dx, we want to find y, we need to take the integral. So we need to figure out what our u is and what our, for u substitution, our u is going to be natural log. And this is kind of neat because our du is 1 over x dx, which is kind of hiding. There's the 1 over x. So this one's actually pretty much done for us. All we have is 1 over u du. Our answer is natural log of u, which is the natural log of x plus c. Okay, this next one, we're going to show you how we get these trig identities, how we get the integrals. So we're going to use sine x over cosine x, which is the same thing as tangent. Our u would be the bottom. Du is negative sine x dx. We don't need that negative. So we have the integral of 1 over u du, which is negative natural log of u plus c, which is negative natural log absolute value cosine x plus c. So you're actually going to be able to just use on the bottom here, we have all the 6 trig functions, but this is how we get them, and it's just kind of cool to see that. When we derive the secant formula, this is kind of a trick that you wouldn't think of, and you will never have to think of because you can just use the equation like I said, but we're going to show you just how we get there. We're going to multiply the whole thing by secant plus tangent because that's pretty much the same thing as multiplying by 1. This turns into secant squared plus secant tangent all over secant plus tangent. And then this turns into a natural log u substitution problem. Our u is secant plus tangent on the bottom. The derivative of that is secant tangent plus secant squared, which it turns out is exactly what we have on the top right now. So we just have the integral of 1 over u du. So natural log of whatever our u was, which is secant plus tangent plus c. Now that I showed you how to do those, we don't ever have to do that again. It's just we can use these on the bottom. It's just kind of neat to see that. Right, we have 2 more problems here. Next one is a definite integral, so we're going to have to use the fundamental theorem of calculus. First, we have to use a trig identity. 1 plus tangent squared is actually secant squared, which means that we're taking the square root of secant squared, which would just be secant. From the previous page, we just saw what the integral of secant was. It's the natural log absolute value of secant x plus tangent x, evaluated from 0 to pi over 4, which turns out to be the natural log of the square root of 2 plus 1 minus natural log of 1, which is approximately 0.881. And last one is to find an average value. Remember, to find the average value, we're taking the integral of 1 over b minus a from a to b of whatever our function is, so it's tangent. This turns into 4 over pi on the outside. Integral of tangent is negative natural log absolute value of cosine. We just showed you that one too. Evaluated from 0 to pi over 4 is negative 4 over pi times natural log of the square root of 2 over 2 minus natural log of 1, which is about 0.441. Okay, so in this section, just skip number 26. Other than that, that was section 2 on taking the integral of natural log functions.